Okay, let's have a look at alcohols. So naming is just the prefix with anol, methanol, ethanol, propanol, and so on. And we can have primary, secondary, or tertiary alcohols as such. So primary is the carbon with the OH has only one other carbon attached. Secondary, the carbon with the OH has two other carbons attached. Tertiary, the carbon with the OH has three other carbons attached to it. Now, alcohols have hydrogen bonding, which results in higher melting and boiling points than alkanes because the intermolecular forces are stronger. As the carbon chain gets longer, the melting and boiling point rises, and the solubility in polar solvents decreases. So what we find is that short-chain alcohols are soluble in water up to about butanol. Then after that, solubility decreases. Once we get beyond 6, they're more or less insoluble in water. And the reason for that is that as the carbon chain gets longer and longer, the non-polar part of the molecule becomes a larger and larger percentage of the molecule. Secondary and tertiary alcohols can be optical isomers, primary alcohols cannot. And we must have a carbon that has 4 different atoms or groups attached to it in order for it to be optically active. Okay, we're going to look at the following reactions: combustion, oxidation, chlorination, dehydration or elimination, and condensation. Firstly, combustion, just reacting with oxygen, we get carbon dioxide and water. If we have incomplete combustion, we'll get carbon monoxide or carbon. Oxidation, okay, so firstly, alcohols oxidize firstly to an aldehyde. So we've got an example here of ethanol being oxidized to ethanal. And then aldehydes are easily oxidized, so if we allow oxidation to continue, it will be further oxidized to carboxylic acid, in this case ethanoic acid. So that was the oxidation of a primary alcohol. The oxidation of a secondary alcohol produces a ketone. So for example, the oxidation of propan-2-enol, propan-2-ol, will result in propanone. So this is a ketone. Okay, so that's the oxidant. It has to be a strong oxidant like dichromate or permanganate. Oxidizing a secondary alcohol produces a ketone. Chlorination, we can use SOCl2 or PCl3 or PCl5. These are chlorinating agents. Produces a substitution reaction where the OH is replaced with a Cl. This is just one example of that taking place. Another example is if we use concentrated hydrochloric acid. I think this one has to be a tertiary alcohol. The reaction happens more easily with tertiary alcohol than with the primary or secondary alcohol. So again, we get the OH being replaced with a Cl, H2O as a byproduct. Okay, we can also have a dehydration or elimination reaction where we produce an alkene from an alcohol. So that's where we eliminate water, hence the name dehydration, eliminating water. So imagine this H and OH here being taken out and a double bond being formed in place of that H and OH. And we need, the most common way of doing that is using concentrated sulfuric acid and heat. Okay, in elimination reactions, we apply Markovnikov's rule that the pore get poorer. So there are 2 possibilities. In this molecule here, if we carry out an elimination reaction, we could eliminate OH and OH here, or we could eliminate OH and OH here. Okay, it's going to be the OH that goes, and also a neighboring hydrogen, could be from this side or this side, forming the double bond either here or here. The general rule is that to form the major product, the pore gets poorer. So which of these 2 carbons is poorer? Well, this carbon here is poorer. So the major product is going to be where this carbon loses its hydrogen and forms the double bond. As you see up here, that's the major product. And the minor product is where this carbon loses its hydrogen and the double bond forms between the first and second carbons. So we get two different products, butyne and but-2-ene, but we get more but-2-ene. That's our major product. A test for tertiary alcohols is using a reagent called a Lucas reagent, which is hydrochloric acid and zinc chloride, and we get a substitution reaction where chlorine replaces the OH. Like we say here, Lucas reagent is used to distinguish between primary, secondary, and tertiary alcohols. The chloroalkane that's produced, so we get a chloroalkane, that's what this is insoluble in water and appears cloudy. So we'll find that a tertiary alcohol is more reactive with Lucas reagent. It will go cloudy immediately, so it's immediately produced the chloroalkane. The secondary will go cloudy, but not until after a few minutes, and the primary will have no reaction even in warm water. So the rate of reaction is fastest with tertiary, slower with secondary, and slower with primary. Okay, another reaction is reaction of an alcohol with a carboxylic acid. This is called a condensation reaction, and we need concentrated sulfuric acid as a catalyst, and this forms an ester. We're going to look at esters separately, but just to know for now that the reaction between an alcohol and a carboxylic acid produces an ester. Okay, so that's alcohols.